Welcome to today's webinar. The topic today is modeling and design of solid elements in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the Dlubal website, the German and English webinars, newsletters, customer projects, and so on. I will be the moderator and also the presenter of today's webinar. I will be supported by my two colleagues, but they can introduce themselves.
Yeah, hello, my name is Stefan Frenzel. I'm working here at Dlubal in the development of the dynamic add-ons and of course in the customer support, and I will answer your questions today.
Hello, my name is Frank Vollstich. I'm responsible for product engineering and quality management. And today I will answer your questions.
Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screen. Some words for the attendees who participate the first time in a Dlubal webinar. You can show or hide your control panel and then ask your question in that field here, and my colleagues will answer you. If you don't get an answer during the webinar because there are too many, you will get an email after the webinar. The other way is to watch the entire webinar and then email questions to info@dlubal.com. Okay, to the agenda today. I will model this connection here, such a solid element with a bolt here. And then I will do a stress analysis for the steel components and also for the line welds. Here are line welds at the end of the webinar. And then I will do a result evaluation and a documentation. Okay, before I start the presentation, a small hint to our booth on the BAU in Munich in April. You can book your live presentation and you can secure your free ticket. Just click that link here, or you can scan the QR code. At the end of the webinar, I will show you where you can find the PowerPoint slides, and then you can book your live demo if you want to visit our booth at the BAU. The webinar will be recorded. You will get an email in the next days with a link to the website with the video and the model and the PowerPoint slides. You will also get the attendee certificate. I will show you the website at the end of the webinar. Okay, then let's start. In RFEM 6, I create a new file. So I call it connection. Okay, 3D. Also members, faces, and important, the solids are activated by default. I activate the design add-on stress strain analysis. And if I click on the standards, you can see all is gray. The add-on stress strain analysis designs not according to a standard, but the stresses will be compared with the maximum stresses. Okay, that's why there is new design code or a standard activated. So at first, I will modify the grid. At the bottom, right-click, edit. I would like to have a space between the grid points of 1 centimeter. Our connection is only 10 by 15 centimeters large. So I change the units for the lengths from meter to centimeters. Okay. So, and then I change the grid to 1 centimeter. Okay. Right above, I change the work plane to XZ, and I look in minus Y direction. Okay, I zoom in. So now I can start here left above with a new line. So 3 lines, 10 centimeters large, and I will stay in the dialog, but I change to arc. So, and I draw an arc. Okay, that's all. And we can create the first surface, yeah? The edge of the solid. Here left above, I select the boundary lines. So, and we have to define the thickness and the material with that button here, create new thickness. The thickness can be 1 millimeter. It doesn't matter. When I create the solid or extrude the surface to a solid, the surface will be without thickness. Okay, the material is okay, as the steel S235, but I show you where you can find it in the library. European steel, and I select the steel S235. Okay. Okay. So I select the boundary lines, and the surface was created. Then I create an opening here left above, opening circle with a radius of 2 centimeters. Okay. So, and now left above here, a new node. I create a new node on that point here. And I use here right above the function, the connect selected lines, in that case at intersection. So now the circle is divided and there are 2 lines. The reason for that is that later I will create the bolt, and between the bolt and the and that surface, or in that case the solid, I will create a contact solid, and the load on the bolt should be only on that side of the bolt. Yeah, force in X direction. That's the reason why I did that. Okay. Now I create a solid. Right click on the surface and then extrude surface into solid. And it depends on the surface coordinate system, in which direction is minus and in which direction is plus. In that case, in plus direction, it goes to that side. I switch, or I extrude it to the other side. That's why I select here or enter here -7. Material is okay, and the boundary surfaces should be without thickness. I apply, okay, and the solid was created. And now that boundary surfaces are without thickness. Means that the surfaces haven't got any stiffness. So then I change to the view in -y direction again. So, or at first I double click on the solid. That was wrong. On that point. Or you can also search the solid here on the left side in the navigator data and double click or right click and edit the solid. So there's a stress strain analysis configuration. It's default at the moment. I would like to edit it to check that. Yeah, and it's quite okay. Tau max. The sigma 1 to 3 and the sigma with the equivalent stresses. So, and those are the principal stresses, the sigma 1 to 3. Okay. Okay. So now I create the next surface, a circle. No, that was wrong. That was the next step should be, I would like to create the solid that we, I will show you what I do. Just a moment. I select that node here and copy it in minus z direction, -2 centimeters. So I create a copy and change the work plane in XY. Okay. And I change the work plane origin to that side. Okay. So I deselect those this solid, hide selected objects, and I view in Z direction. So, and I create a new surface, a rectangle. Yeah, that thickness is quite okay. And from that point to that point. So, and I extrude it. So, yeah, 20 centimeters. Okay. Yeah, for that solid, we can choose, for example, material timber. Okay. Because in the next step we will do the operation this solid minus this solid with the Boolean operations. So I cancel the visibility mode and so. Okay. So, and in the next step, as I said, I deselect or I delete this node. In the next step, we will subtract this solid from this solid. So I do a right click on that solid and I edit it. So, and I choose the solid type hole. Okay. Can't be, that's okay. So, and now the new solid was created. That's the original solid. That's the hole. And this one is subtracted by this one. And we subtract this one from this one, and that's the new solid. Okay. So, and I do right click on the generated solid, edit, and left on the left side at the bottom, I cancel the generated state because we would like to work only with this solid. Okay. Okay. So, and now we can delete the whole solid. Right click, edit. No, right click, and then not only delete, but delete with boundary surfaces. That's quite important. Okay. And now our main solid was created. I can go in the table. Where are the solids? I delete those lines, delete row, delete row. Okay, now our solid is solid number 1. Now it's better for the overview. So then the next step, I change the work plane to XZ and the origin to that point. Okay. The work plane is correct, and we take a look in -y direction. So in the next step, we create the circle. With the same thickness and the same material, that's okay. So, and with a radius of 1.9 centimeters. So, and we divide the circle with a line. I change to the wireframe model. Here left above with a new line. Okay, in the middle. So, and then right above with the same function, connect selected lines at intersection. Okay, I can delete this line. And now the lines for the bolt is also divided in 2 parts. So then I extrude it. It's better for the overview. I extrude this circle as well. Surface into solid. In -2 centimeters as 235. Okay. So. And now I would like to create the contact solid. Only 1/2 here, such a ring in the space between this main solid and the bolt. And that space here. If you wouldn't have any space between the surfaces, those are the boundary surfaces. And when you haven't any space between them, you can create. I will show you surface releases, such surface releases. But I will use the space for a contact solid. So that's why. In the next step, I will create the boundary surfaces. I create a new surface, polygon in that case, without thickness this time. Okay. I start with this one. Okay. So I zoom a little bit out and in. So the same at the bottom. Okay. Then another function, select boundary. Without thickness. I forgot to do it for width of that surface. I will change that later. Okay. Okay. So, and I can double click on it and change it to without thickness. Okay. So I copied that surface from that point to that point. Okay. So now all boundary surfaces are created, and I can create the new solid, the contact solid. With that button here, new set new solid, or you can right click here and define or select new solid. So standard, yeah, at the moment standard is okay. We will change it later. I select the boundary surfaces. So this one, I have to deselect the autocomplete. So this one, this one, this one, this one. Change to the wireframe model. This one, and only one is remaining. Okay, we can check it. So that's okay. Okay. Yeah, and we can also change it to the contact solid. And we have to define the contact conditions. So with that button here, create new contact. There are different possibilities, full force transmission, failure under compression, failure under tension. We will use failure under tension. That the bolt isn't glued and at the edge of the hole. So then here, rigid friction, yeah, you can see different possibilities. Rigid friction, yeah, I define a small friction factor. We won't have any friction in our system. Okay, so, and we have to define the opposite surfaces, that surface and that surface. There are already a proposal, 28 and 31. We have to check it. Yeah, 28, and I have to go to the wireframe model. 28 and 31. Yeah, that's okay. So I can leave the dialog, and the contact solid was created. You can select it, and you can see it. Yeah, in the space between the bolt and the plate here. So now I mirror the contact solid with that function here. Create copy. YZ is the plane, and I select the point, the middle of the circle. Okay, that's all. That part of the bolt and the contact solid was created. So I copy the complete bolt to the other side. Copy, I have to change the vector from here to here. Okay. So, and in the next step, I have to fill out the space and the overhang. I enlarge the bolt here. So with the extrude function, 3 centimeters, S255. Okay, same on the other side. That goes quite quickly. So -3. Okay. And the space here. Also -3. Okay. So the model is complete. What is the missing? Yeah, we will support in the first step that surface, edit surface, and I add supports. Here above, I change the dialog, support, create a new support. Now it should be rigid in all directions, or fixed in all directions. Okay. So, and now, yeah, for that we can check if the model is complete and is okay, we calculate the self-weight load case that was created automatically. Yeah, it should be fine. Okay. So, and you can see there is a quite rough mesh, and I would like to show you a function or a feature. So in the navigator display, you can see the mesh. You can disable it, and I would like to introduce that setting here, or that function, mesh quality. Where is my panel? That's on the other screen. Okay. And when you click that button here, you can see the mesh quality. Yeah, 80% are okay. Yeah, for 20% are a warning. That's quite clear with such a rough mesh. I can show you the mesh settings. Yeah, that's quite rough. We change it to 1 centimeter, and you can see the quality criteria for the solids in the dialog here. If you have a ratio larger than 1 to 20 for the sizes of the mesh or of the element, then you will get a warning and a failure with that aspect ratio and parallel deviation and so on. Okay, and apply. The program creates a new mesh, and you can see 99% are okay, only 1% deliver a warning. Yeah, I will calculate with that mesh because I would like to get a short calculation time in that webinar. Actually, we recommend minimum 4 or 5 elements on the smallest size here. At the moment, there are only 2 elements, but for the webinar and to save calculation time, it's quite okay. I can disable the mesh quality. Okay, and I can also, with that setting or with that setting here, disable the mesh. Okay, then we have to apply a load on, as I already mentioned, on that surface and that surface and that surface. Okay. So I would like to apply a load of, or 3 loads of 35 kilonewton but I have to apply it as surface load. That's why we have to calculate the surface load. I measure with a double click. I can edit the surface, and I can it displays the area of the surface. To have the exact the exact value, I have to on the left side at the bottom. I can change the units and decimal places for the areas here to 6 decimal places. Okay. Now, and I can write down the value here for the surface number 57. Okay. So then I apply a new surface load. So in X direction, and 45 divided by 0.00177. Okay, and the program calculates the parameter or the load automatically. So I have to select the surfaces, this surface. Okay. I can do that because all surfaces have the same size in that case here. Otherwise, you have to create more loads. Okay, so we can move the load a little bit. Okay. So you can also find the load on the. Oh, I have to change the taskbar that I can see all. Okay, in the navigator data, you can search for the load. Actually, or at the moment, it is the self-weight load case. We will change that. I can see the surface load here, and if you double click on it, we reached in the same dialog. I would like to show you another possibility to calculate the load, the surface load, with a formula. So I enter 45,000 Newton, SE units. We have to use SE units divided by, and here with that info button, you reach that table with different object properties. So I search for SU. So then surfaces, other surfaces and area. Okay. Okay. And I enter area number 57. Okay, and you can see the surface load was calculated, and you see there is a small difference. Only a small difference, but that is the correct value. Okay. And if you want to change the load later, you can go to the formula and only enter the load here. Okay. I think it's a really good feature. So in the next step, I go to the load cases and combinations. Load cases and combinations. So that's the current load case. I call it FD. We apply loads with safety that contain already a safety factor. So then the design situations, I delete the design situations for the serviceability limit state. We only work with the ultimate limit state, and we have to activate the stress strain analysis for it. we although we have got only one load combination, one load, we have to create a design situations because you can activate the add-ons only for design situations in RFEM 6. Okay, I turn to the base data. I disable the combination wizard and keep the load combinations. I only change the safety factor because we already have got design loads. So, okay, design situation contains only this load case. So, and then we can calculate all. So, and we take a look at the solid results, for example, the sigma x. And you can see where are, on this side of the bolt is pressure, here tension for the sigma x, and there's no tension on that side. We can also take a look at deformation, and we can also animate it. Okay, let's disable the contact solid. Here, left at the bottom, the views. There we can find the visibilities, and we select the visibility for solids by type, and we display only the standard solids. So, and we take a look in -y direction. Okay, and I can animate it again. And you can see the bolt can be released from the edge of the hole because of the contact solid. Okay. So then we can also take a look at the bottom on the table, stress strain analysis. Okay, configuration is deactivated. I have forgot something. We have to define for all the standard solids by right-click the stress strain analysis configuration. We use for all the same the default setting. Okay. Now we have to do the stress strain analysis again. Okay. Yeah, those are the results. The maximum stress ratio is for the principal stresses, sigma 1, 2, 3. That's tau max, and those are the equivalent stresses. Yeah, we did an elastic design. If you perform plastic design, you can apply, in my eyes, higher loads. But then you have to check the strain in the static analysis. Strain equivalent total strains. When you do a plastic design, the maximum plastic strain should be 5% according to Eurocode. At the moment, we have got only elastic strain of about 0.1%. Okay, so in the next step, I would like to define the line welded joints. cancel the visibility mode. Okay, I delete the support. Okay. So, and I copy that surface here with the same function that we already used. Move and copy, create a copy, -2 centimeters, in that direction 0. Okay. So I would like to increase the size of the plate. Just a moment, I disable or hide the selected objects. Change the work plane to YZ. Okay. New origin. So, okay. Okay. And I take a look in X direction. So, and I can drag and drop the nodes. Okay. So I only have to change the setting of the surface. Double click. At the moment it's without thickness. I change it to standard. And I create a new thickness. 20 millimeters. Okay. S235. That's okay. Okay. So now I moved that plate here because we can't create a line welded joints on a surface without thickness. That's why we have to create a surface with thickness in that space here. So I cancel the visibility mode. So, and I select the 4 lines with the control key. Okay. I copy them. -2 centimeters. Okay. And with that button here, a new dialog is opened. And I can select linked lines with surface. I select the template. We are the same. We use the same thickness, 20 millimeters. Okay. And now the space is filled. So, and now on the left side in the navigator data, you can find the types for lines and here the line welded joints. By right click, I can select new line welded joint. So we have to define the joint type. There are butt joints, corner joints. There you can see the preview on the right side, the lap joints and the T-joint. We will use the T-joint. In our case, single filled, that's okay. Continuous, and I define the weld size of 10 millimeters. And I have to select the lines and surfaces. So I change to the wireframe model. At first I have to select the line, then the area to be connected, and then the base plate. So add new object here on the left side, same procedure, line, area to be connected, and the base plate. So we have to do that 4 times. Line, surface number 1 and surface number 2. And also here. Okay. 64 is the base plate. It's on the right side, and it should be okay. So, and those are the line welded joints. I go in the dialog again. And we have to define the stress strain analysis configuration. It's by default. We can edit it if we want. Yeah, that's empty because, as I said at the beginning, the stress strain analysis add-on calculates not according to a standard. Yeah, and you have to calculate the limit stress, with the certain correlation coefficient according to the standard. Okay. So we perform a stress strain analysis again. Okay. I forgot to support the plate here. I double click on it. Support. Rigid. Okay. So next try. With the rough mesh, we get the results immediately. So those are the solid stresses. We can also go to the table. Stresses on solids are the same results as before. And here the stresses, the stresses in the line welds. Okay. Yeah. That's all. Change it to this one. Yeah, and you can use different options for the result evaluation. For example, when you go in the navigator data and the guide objects, there are clipping planes, clipping boxes, and so on. To print it, maybe in the printout report, you can also use the function sections. Also here above, new result section. Let's create one or two sections. I create the section with 2 points and vector. Okay, I select 2 nodes. For example, this one and this one. And we can modify the values. For example, the X value from 10 to 15 for the second point, 15. And if you want to get the results in the middle of that plate here, we can also move the section in minus Y direction. That's why we enter 6 here instead of 7 and apply it. Okay, so and in the result navigator, we can find the result sections, and I can activate it, and you see the results for the different stresses. So let's create another section. Maybe we would like to create a section in the middle of the board here, a horizontal section. I can double click, for example, on the results section and copy this one and change the projection from Z to Y. And I have to change some values, not minus 10 at the top, so not in the middle, but in the middle, minus 5 centimeters. Okay. Yeah, that's all. Okay. And if I only activate section number 2, I can take a look at the results. Yeah, and then you can print such sections in the printout report. And in that case, here seems to be the maximum value. I print only this view here in the printout report. But for example, for the principal stress, tau stress, and the equivalent stress. How to do that? Here left at the top, print graphics to printout report. So at first we define window filling, and yeah, you can print the current only or a multi-print. And let's use the multi-print option. Then we have to click on the different dialogues here. For the model, I use the current view, then in Z direction, in -X and -Y direction. And the loads, only the load case number 1 in the current view. And the results of the add-on. Now we don't need those results, only the add-on. Solids, the stresses in the tau, sigma for the principal stresses and equivalent stress. Okay, in the current view. Yeah, that's okay. And if we switch to the general dialog here, takes a short time to create the images. Then we have got a preview of the model in the different directions, then the loads and the different stresses. So then we can save and show the printout report. Yeah, you can give him a name. You can select the items here. Yeah, for example, the line welded joints. Then for the stress analysis, we can deselect the stresses on surfaces. The surfaces were only help surfaces for the line welded joints, but we select the stresses on solid by solid. Yeah, that's quite okay. And we can generate the printout report. Yeah, and that way you can, also with the multi-print function, you can print different other views in the printout report. So let's take a look, for example, for this graphics. Now we saw it already. Then the line welded joints, can zoom a little bit in. Those are the parameters. The weld size 10 centimeter. Surface supports the contact conditions, failure under tension, rigid friction, and so on. Then the loading. So the loading. Then the stresses on solids, the different parts and belonging stress ratios, and the stresses in line. welds by line, and the graphics for the stresses. Okay. Yeah, that should be all for the presentation. Before I close the webinar, I would like to show you two slides, and I will show you also the website where you can find the recording and the finished model and the PowerPoint slides. I turn to our website, dlubal.com, or at first I showed the PowerPoint. Yeah, again, maybe some of you take part in the middle of the webinar or miss the start. Just book your live presentation at the bar. We have a booth there. You will get a free ticket when you click on that link or scan the QR code, where are experts on our booth that can advise you. So the next slide. If you want to improve your skills for the steel design, for example, you can take part in a training. It costs 250 euros. Not much when you work quickly after the online training. More information and registration can you find here when you click on that button, or you can also scan the QR code. You can also book your free online appointment by our sales team. They can create an offer for you for our products, or you can get a free product presentation. Just contact our sales team with that button or the QR code. So now I show you our website, dlubal.com, and under news and events, you can find the webinars. That's today's webinar. That's the webinars of the next week. Steel silo design in RFEM 6, then the FAQ webinar. I will present it on next Thursday. Modeling sections in our section, and so on. And then our previous webinars. So when you click on today's webinar, in the next days, you will find the recording here. And you will get an email with a link to that page, also with your certificate. You can find the presentation slides with the hints for the BAU or the online training. You can download it, and then you can find the trainings and so on. And at the bottom, you can already download the finished model. I presented the webinar also already in German, and that's why we have got the model to download here. Okay, that should be all to this webinar. I would like to say thank you for your attention. Thank you to my two colleagues for answering your questions. Maybe a last hint when you leave the webinar, there's a small survey. It would be very nice when you answer the questions or when you score the webinar. Just note that the worst score is 1 and the best score is 5. You can enter your wishes for future webinars, for example. You can also leave it empty or enter a minus or something or other sign. It would be very nice. Okay, thanks again. I wish all a nice rest of the day. It's a sunny day here in Germany. I hope in your country as well. Bye-bye.